Okay, now let us see how we use the geometrical approach. We have seen the vector approach, now let us concentrate on the geometry approach. I'm going to hand this and then this. So, ship A is sailing at 60 kilometers per hour due east, and ship B is sailing at 50 kilometers per hour in the direction of north 60 degrees towards the west. Find the velocity of A relative to B. So in simple terms, what we do, we draw a simple sketch. So we have here, you draw that compass, then you base on everything, you are going to put it on that. Now, we have first of all, A is sailing at 60 kilometers per hour due east. So, due east. So our due east, now due east, this is going to be our direction, due east. Okay, and then ship B is sailing in the direction of north 60 towards the west. So this is first of all our due east. So due east in that direction, this is our north. So due east is at 60 kilometers per hour. And ship B is sailing at the direction of north 60. So this is going to be from the north, we measure off 60. Then the north we measure off 60. That is going to be the direction of ship B. So this ship B is sailing at 50 kilometers per hour. Now from there, find the velocity of A relative to B. So if they say A relative to B, it means that the direction of B has to change. So it appears as if it's changing relative to. So this is going to be our, this is going to be now, it's going to be our negative B. It appears on our V of B, which is going to be 50. Why are we taking it? Because it's just appeared. The magnitude of the velocity is not going to change, but its direction appears as if it's changing. So this is our VA, and this is our VB equal to that. Now, you see to get the resultant means that I will get the positive of this plus the negative of this. So, meaning I can now extrapolate also this in this format. It's still due west. So this is going to be now my 60 kilometers per hour. Then to get relative, then I will add this plus the negative of this. So that's why now I'm free. Now connecting this to this one here. Okay, so now this is going to be A relative to B. The direction of this is maintained, but the direction of this B is going to change. We are going to add a negative of that B. Okay, so if this is 60, then this one is also going to be 60. And remember, this is 9. So the whole of this is 150. So we can also get, so from there, after we shall put the compass here. Remember, in this one, this is 60, then this will be 60. So we shall name this angle, or we shall use this angle, theta there. So what are you going to use? We are going to use the cosine. So because the whole of this from here now up here is going to be 60 plus 90, which is 150 degrees. We have this, we have this angle, we can aggregate now this. Okay, so from there you can see A relative to B squared will be equal to now 60 squared plus 50 squared. This one I don't think we are just showing the negative of it, but the magnitude of the velocity is positive. That's why it remains positive. The magnitude of this, it appears as if it's, because it's just negative. Then minus 2 into 60 into 50, then cos of 150 degrees. From there, A relative to B, we get the square root of the whole of that. here I'm getting 106.2834 kilometers per hour. So now the direction means that now we first get this theta here. If we have this theta, then we shall add on that 60. So we have this, we have this, we have this, we need this, we have this and this. So from there, using sine rule, so we are going to apply our sine rule there. We shall see that now we have every b, we have 106.2834 over sine of the opposite angle, which is this. It will be equal to now the angle we want, so the 60 over sine theta. And from there, when you simplify, you see that you will get this times this divided by this. So 60 getting 16.4 degrees if I round it to 1 decimal place. But now, this angle here, remember I'm not read it from the north line, because this is our north. So meaning the bearing is going to be 60, but now this. Therefore, my bearing is going to be, so I need 60 plus the theta, which will be 60 plus 16.4, which will give us 76.4 degrees. So therefore, our bearing is north. From the north, we shall go. From the north, we shall move 76.4 degrees. Towards system, we shall go towards, so we need the whole of this, towards the west. And that's what we will be. So that's how we start. Let us come to this. The cyclist riding at 40 kilometers per hour due north. So you have a cyclist which is traveling at due north. So he's going due north. So we have him, that is our compass. It's going due north. This is our north at a velocity due north at 40 kilometers per hour. Wind appears, the moment you hear the word appears, means they are giving us that wind appears to blow at from the west. Now the wind appears to blow at 30 kilometers per hour from the west. This is our west. So it appears as if it's coming from this side, from the west. So this is the velocity of the cyclist. Now this is the relative velocity of the wind. So the relative velocity of the wind relative to that of the cyclist. They are telling us because of the word appears 30 kilometers per hour. Find the true velocity of the wind. It means that if we have wind relative to, it means that we shall get the velocity of the wind plus the negative velocity of the cyclist. So meaning, we shall get this negative of the cyclist in this direction. We shall see this one is going to be now negative of C, which is 40 kilometers per hour. Then after getting that negative, we shall add on the velocity of the wind. We shall add on the velocity of the wind, which will be the true velocity of the wind. But here, we shall be adding our relative velocity. So meaning, this is going to be our W relative to the cyclist, which is 30 kilometers per hour. Okay, so if I call this, let me call this alpha. So it's that now, of course, this is going to be a right angle triangle. So whenever you see the word relative, this is W, let me make it clear. So you see, this means we shall get the positive of the wind plus the negative of the cyclist. That's why for the cyclist now we are moving to the opposite. Then we add a positive of the wind. Here the same case. The one that's left A relative to B. We get the positive of A. I think you see the positive of A. This is, yeah, it's the positive of A. The positive of A plus the negative of B. So this one now changes the direction. I think you get it there. So it's what we are doing there also. Good enough, this triangle is right angle, so we can easily get this. We have this, we can get this because we can use Pythagoras. Even if you want, you can also use cosine rules, then give you the same answer. Because they are respect to be 0. Okay, you can say using Pythagoras theorem. Now, what are we having? We shall get now our V squared W equal to 40 squared plus 30 squared. And our V W from there will be 50 kilometers per hour, as simple as that. Or you can use cosine rules. Cosine rules. It's going to give you the same answer. From here you can see we shall be having V squared W equal to 40 squared plus 30 squared minus 3 into 40 into 30 cos of 90 degrees, cos of the angle opposite. But cos of 90 is 0. So we should be having W squared equal to 40 squared by 30 squared minus 0. And your W still will give you 50 kilometers per hour. It's up to you. All of them will give you the same answer. Okay, we want now the direction. We have the rest, but now we need the direction. How do you get the direction? Now I have this. I need this. I have this. I need it. I have also that. So using sine rule, whenever we are getting angles in parallelogram of vectors or triangle vectors, we use sine rule. So from there, you can see this is opposite. So we have 30 over sine alpha to be equal to this one, VW, which is 50 over sine 90, but this is 1. So we get 3 so I'm getting my alpha as 36.87 degrees. So meaning now my bearing, therefore direction is from here is now we are this one. If you draw this is a north line, because when you draw this diagram here, I think you can see how it's going to appear. You see? So meaning it's going to be now it's going to be, so if I'm to draw, okay, the direction is 036.87 degrees, or say north 36.87 towards the east. All those are described being the same thing. So that's how we handle that, members. I wish you well.